Hey everybody, this particular video is going to be the first of 4 in a series that I'm going to call What's the Move? What is the move? Those are the actions that take place when you are doing math. Those 4 moves are addition, subtraction, multiplication, and division. It's important to note that students have to understand what is happening within the problems, what actions are taking place within the problems that they are reading. If they can connect an action to an actual mathematical process, it helps you and them better understand what math is taking place within the problem. Math is happening everywhere, and so we want them to be able to see the math, not just do the math. So here's to part 1. Part 1 is going to be over addition. Our first move is addition. Hope you guys enjoy. All right, our move for the day is addition. What we do when we add is put things together. So to help us with representing each type of addition, we are going to be using the same numbers, 473 plus 189. Okay, as you can see, I've kind of already set up each type just to save time, but we're going to get into it. Okay, the first one is base 10. As you can see, I've represented those numbers with 4 in the hundreds place, 7 tens, so that represents our 70, and then our 3 ones to make 473. The adding portion is 100 plus the 8 tens that make 80, and then the 9 ones. So as usual, when we do the algorithm, we're going to combine starting in the ones place. As you can see though, our ones are in pictures. So the way that we combine within a picture is just basically circling the group of ones that make a 10 and circling the groups of 10 that make 100. Okay, so starting in the ones place, we're going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once I get to 10 ones, I know that creates another 10. So I'm going to circle those ones that combine to make a 10. And then to show that I'm regrouping or moving them to the tens place, I'm going to actually put that additional 10 in the tens place. And notice that I'm making it a little bit darker. That's so we can see which one I regrouped. Okay, and then if there's enough to make another 10, then I would. But in this case, there is not. There's only 2 ones left. So that will be my digit that goes in the ones place. Moving on to the tens. Because I'm in the tens place, I want to make sure that I count by 10. So that would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Notice that I counted the one that I regrouped as well. But I'm going to combine those tens that make 100. And make sure I have 10 tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yes. Those regroup to create an extra 100. If I have enough to make another 10, another 100, then I would, but I'm going to count those that I have left. 1, 2, 3, 4, 5, 6. So that will be 6 tens. Okay, and now I'm going to combine the hundreds. When I combine the hundreds, that's 100, 200, 300, 400, 500, 600. So there are 6 hundreds, which will make my sum 662. Okay, now we're going to see that exact same thing, but we're going to represent it on the number line. So as you can see, I've created a number line. My starting point is 473. I'm going to show how you would add 189 to this amount. And we show on the number line, we use jumps. So my first jump would represent the 100 in the second number, 189. So that would be 100. If I add 100 to that, that would be 573. Again, and I also point out with the students that when I add by the hundreds place, that is the only place that's changing. It went from 4 hundreds to 500s. Now I need to represent the jump of 80. Now I've seen this done different ways, but I'm just going to go ahead and do one jump of 80 to represent that. So if I add 80 to that, that will create a sum of 663. Sorry, 653. Now, because decomposition or breaking apart of a particular number can be done in different ways, the way that I'm going to use for the 9 is I'm actually going to use a friendly number. So instead of jumping the whole 9, I'm going to just jump 7. Why did I do that? Because I want to get to a friendly number. If I add 7 to this, it's going to come up to 660. That way I get to a friendly number. From there, I would add 2 more, or another jump of 2. And then that would equal, of course, our sum of 662. Well, you might be wondering, well, where is the number that I'm adding? Where is the 189? It's actually represented through your jumps. When we combine all of these numbers, it equals our 189, the number that we're adding. So again, they want the students to know how to come up with the solution in different ways. And this is one of those ways, the number line. I'm going to come back to these two because these two are probably the last things that they will see. They want them to be able to represent the other ways. I'm going to go down to strip diagrams. Strip diagrams are pretty common, a pretty common way to see our movement, our action, our math that we're doing within problems. So I drew this first box to represent the 473. And within a strip diagram, what they can do to show that you are putting numbers together, they will usually attach like a dotted line to show that there will be an additional 189. And then when you combine those two amounts, when we put those two together and they'll show with these arrows, we will get our solution. With strip diagrams, you usually don't actually solve for, so that is why I put the question mark. We just need to be able to see what it would look like if we were showing it through a pictorial model. This is another type of strip diagram that they show where instead of having them together, they are separated. So this box will represent the 473 because it is the bigger value. And then the smaller box will be representing the 189. Okay, and the way they show in this model that the two of them are being put together is they'll use arrows again to show that this value is being put together with this value to come up with our solution. Now, in addition to strip diagrams, they also do use other methods. One of the methods that I've noticed being used is part whole. So notice that this is a rectangular box. We draw a line within that box to separate our part from our whole. Now with this, students have to know what each part of the addition number sentence is. The whole, of course, can be represented on either the top or the bottom. So I'm just going to use the top. I'm sorry, I'll do the bottom just because I haven't done the bottom. Put the question mark there. That's my whole. I don't know what the whole is. When we add, we work to find the whole. But I do have my two parts. I do know that one part that I am putting together is 189. So I will represent that with the smaller portion. And then I do know my other part that I'm combining, which is 473. Okay, again, another way to represent, we're putting those two amounts together to find our whole. I've also seen it done this way, where this circle will represent the whole. The circle will represent the whole, which we don't know. So we put a question mark in there. Sometimes they may use a letter, but we're just going to use a question mark for this particular example. There will be a smaller circle to represent your smaller value. And then there will be a bigger circle to represent the bigger value. So of course our smaller value would be 189. And then our smaller value would be, not our smaller value, our bigger value would be 473. And to show that we are putting those together to show our move, we're going to use arrows to show the movement. We're combining this part with this part to identify our whole. Now we go into our partial sums. Now partial sums actually coincide with place value, where we're using the expanded form. I have an additional video on expanded form for those of you who are unaware how it looks. But for this purpose, we'll just go ahead and fill it in. A 4 in the hundreds place would have a value of 400. A 7 in the tens place would have a value of 70. And then a 3 in the ones would have a value of 3. Now I'm adding that to the values that represent 189. So a 1 in the hundreds place would be 100 as a value. And then 8 in the tens would represent 80. And then 9 in the ones would represent 9. It would be represented by the number 9. Now, how these sums work, you basically combine them by their places. And the difference between that and the normal algorithm is that you don't regroup. So, when I start in the ones place, that 3 plus 9 will be represented by 12. 70 plus 80 would be 150. And then 400 plus 100 will be 500. And what we would do from there is take those partial sums to create our actual sum. So we would do 500 plus 150 plus 12. And as we will see, we'll get the same sum of 662. And last but not least, the way we all learned the algorithm. And yes, that will probably be the last way that they want the number represented, because they want them to understand not just doing it this way, but how to come up with that same process, that same sum, all the other ways as well. So again, we would start in the one place. 3 plus 9 is 12. Now what I do with regrouping, the 2 would stay there, of course. When I do my regrouping, I'm going to put plus 1 above that next place. And then in addition to that, I'm going to count my regrouping first, because a lot of times students will forget that 1 that they added. So I'm going to do 1 plus 7 tens, that's 8 tens, plus 8 more tens is 16 tens. Can't have all 16 there, of course. So my 6 will remain in the tens place. The 10 tens that make 100 would move over to the hundreds place. So I'm going to put plus 1. And again, add that regrouping first. 1 plus 4 is 5, plus 1 is 6. And those are our multiple representations of this same addition problem. Stay tuned for more moves. I got 3 more operations coming to you. Everybody take care.